thousands and thousands of media literature and theories on this subject, our wonder regarding our place and loneliness in the universe has been constant, as if it is ingrained inside of us to always search for a companion no matter how alien-like. Well, we just might be getting closer and closer to the answers we truly want, but are they truly the answers we are looking for, or are they much more terrifying? Join us as we explore the latest discovery in the realms of galaxies and planets on the quest to find something we just might not be prepared to witness. Lights far, far away, scientists have discovered what could be the most groundbreaking discovery in history. Back in 2012, when the James Webb Space Telescope was scheduled to launch, a very interesting hypothetical question was raised about the capabilities of our technology. The question was whether in the future our telescopes could detect artificial light on another planet. For example, Proxima B, the closest exoplanet to Earth, is in the habitable zone of our nearest neighbor, the dwarf star Proxima Centauri, about 4.25 light-years away. Since the exoplanet was 20 times nearer to its star than the Earth is from the Sun, Proxima B was believed to be tidally locked with a permanent day side and night side, similar to our Moon, which faces Earth with the same side at all times. A hypothetical technological civilization on Proxima B might transfer heat and electricity from the day side to the night side using photovoltaic cells that generate electricity out of starlight. Subsequently, in a paper with Manusvi Lingam as one of the researchers, it was shown that significant coverage of the day side by solar panels could be detected with future telescopes. Since the JWST was more advanced, it would allow us to extend our search for artificial lights to habitable exoplanets like Proxima B. Now, in 2024, it is possible that the James Webb Space Telescope did just that. Using its higher sensitivity and bigger range of capabilities, the JWST might have discovered the lights we were looking for and possibly hurled us into another big surge of human evolution. But first, let us dive into the world of planets and exoplanets to learn how all this was even possible. James Webb's mission explores Proxima Centauri's secrets. Throughout history, humans have wondered about the nature of the universe. What we are, where we come from, and where we go are common yet extremely difficult questions man has tried to answer as soon as he gained consciousness. Now, in the age of exponential technological advancement, one does wonder if we are any closer to any of the above questions. If you would ask a philosopher, he would probably say we are still at level 0 of understanding ourselves in the universe. However, ask an astronomer the same thing and watch him jump up and down in excitement as he rushes to tell you the latest discovery humans made about the universe using their nifty tools. These tools, although not paid much attention to by the average public, are quite literally a manifestation of human evolution itself. We now have the world at our fingertips, and it is time we move forward and get the universe at our fingertips as well. One such way to do that has been deduced by scientists and astronomers. It is through the technology we harness. A specific creation of that said technology is now responsible for the recent discovery of what might be light on a different planet light-years away. Yes, we're talking about the James Webb Space Telescope. The James Webb Space Telescope is the creation born out of the legacies of human expeditions into space to answer some ever-present questions. Are we alone? Who is out there? Where do we begin and where do we end? Well, this infrared astronomy tool has already begun answering these questions, although partially. Well, first you might find yourself asking, what even is Proxima B? Proxima Centauri B, or just Proxima B, is sometimes referred to as Alpha Centauri CB. It is a super-Earth exoplanet, and it orbits an M-type star. Super-Earth exoplanets, M-type stars, confused yet? Do not worry, since this video will quell all of your burning questions. Super-Earths are a class of planets that are more massive than Earth yet lighter than ice giants like Neptune and Uranus. They are truly one of a kind. They can be made up of gas, rock, or even a combination of both, and their sizes can vary from twice the size of Earth all the way to 10 times its mass. They really put the super in super-Earth, huh? As for Proxima B, it is a super-Earth and an exoplanet, meaning that it is a planet that traverses outside the solar system. The very first possible evidence of an exoplanet was found in 1917, although it managed to stir up little curiosity and recognition. However, in 1992, the first confirmed detection occurred, which left scientists speechless. Another exoplanet, a different one which was first detected in 1988, was confirmed in 2003. As of the 1st of April, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems. Out of them, 896 systems had more than one planet. These marvelous discoveries are orbiting an M-type star right now. To explain the M-type star, you need to understand the red dwarf. A red dwarf is the smallest kind of star in the main sequence, hence the name. In the neighboring regions of the Sun, red dwarfs are by far the most common type of star to be found in the Milky Way. They have really low luminosity, and since luminosity is one of our main tools for planet detection and other types of deductions, red dwarfs are not that easy to observe. The sneaky stars have variable definitions and names depending on their temperatures and sizes. For example, M dwarfs or M-type main sequence stars yield a maximum temperature of 3,900 K, hence getting their name and attributes. Coming back to Proxima B, its mass is known to be equivalent to 1.07 Earths. Interestingly, it only takes 11.2 days to complete one orbit of its star compared to our 365.25 days. You can estimate the size of the star Proxima B is orbiting, staggeringly under the measurement of the entire electromagnetic spectrum. The star has a total luminosity of only about 0.16% that of the Sun. Additionally, in the visible light spectrum, its luminosity seems to dull even more as it appears fainter. It only illuminates 0.056% of the Sun's luminosity in the visible light spectrum, emitting a significantly less amount of light energy when compared to the Sun. Over 85% of its emitted energy is in the form of infrared radiation. Orbiting about 0.048 to 0.056 astronomical units away from its star, Proxima B's discovery was announced way back in 2016. You might be wondering, why Proxima B? Millions of stars, planets, and galaxies, so why are we so fixated on this particular celestial body? Well, there are a few reasons. Reasons that contribute to the keen interest astronomers have in this place. First and foremost, Proxima B is the closest known star to our Sun, and by definition, us. Although 4.2 light-years is a big number to us Earthlings, in the grand scheme of the universe, it is a mere blip. Hence why Proxima B, our closest known star, is high up on the priority list at the moment. It is also a part of the triple star system called Alpha Centauri, and although Proxima's luminosity is very low, the system itself appears as one of the brightest constellations in the night sky, only behind two others called Sirius and Canopus. However, the most interesting thing about Proxima Centauri B is that it might potentially be habitable. Since it falls under the habitable zone, the possibilities surrounding the star are endless, and thus astronomers have taken on the expedition to explore the depths and limits of the potential of the star. That is where the James Webb Space Telescope comes in. The four key goals of the JWST are to search for light from the first stars and galaxies that formed in the universe after the Big Bang, study galaxy formation and evolution, understand star and planet formation, and to study planetary systems and the origins of life. As the JWST continues its exploration of the said exoplanet, we get closer and closer to the completion of these missions. From SETI to exoplanets, searching for alien life. So, what exactly is SETI, one might ask? Considering that humans have always been a curious species, poking and prodding into literally anything and everything that moves and doesn't move, it makes sense that a quest like SETI came into existence on such a large scale. Imagine that God has organized a grand cosmic treasure hunt, but with a twist. Instead of gold, we are tasked to be on the lookout for signals, more specifically electromagnetic whispers from civilizations beyond our wildest dreams. SETI is short for the Search for Extraterrestrial Intelligence, and it is a collective effort of multiple organizations, researchers, and of course, giant radio telescopes working to capture any whispers from the universe. While we as a species have come a long way from primitive tools to advanced space telescopes, the universe and its cosmic signals remain mostly an enigma. Although we have theories of the beginning of the universe and what lies beyond, we are still as blind as our forefathers were to the ultimate truth of the vastness of it all. SETI's mission is to find extraterrestrial civilizations and prove that we are not the only ones in this grand cosmic theater. It makes sense that we are curious about the existence of other intelligent beings. After all, if you lived in a vast mansion with countless rooms and hallways, wouldn't you want to know if you were alone or if there were others sharing the space with you? The initiative uses a combination of ground-based radio telescopes like the Arecibo Observatory and the Allen Telescope Array to scan the skies for any unusual signals that might indicate the presence of technologically advanced civilizations. SETI researchers primarily look for narrowband signals which are typically produced by artificial sources rather than natural astrophysical phenomena. The focus is on specific frequencies, such as the water hole, a quiet region of the electromagnetic spectrum near the 1.42 GHz frequency of neutral hydrogen. This is based on the assumption that other civilizations might also choose this frequency for their interstellar communication. As humans, our desire to connect and communicate is one of our most profound traits, and it is this desire that drives SETI. We have always sought to understand the world around us, to find patterns and signals in the noise, and to make sense of the chaos. The search for extraterrestrial intelligence is an extension of this innate curiosity, a quest to find our place in the cosmos, and to perhaps one day make contact with beings who share our desire to explore and understand. Although the search for extraterrestrial intelligence has yet to yield definitive evidence of alien civilizations, it has not been without its moments of intrigue. For example, the famous WOW signal detected by the Big Ear radio telescope in 1977 has yet to be fully explained and remains one of the most tantalizing mysteries in the search for extraterrestrial intelligence. As we continue to develop more advanced technologies and expand our search to other wavelengths and regions of the electromagnetic spectrum, the possibility of making contact with an extraterrestrial civilization becomes more tangible. With the launch of the James Webb Space Telescope and other future missions, our ability to detect and analyze potential signals from other worlds will only improve, bringing us closer to answering the age-old question, are we alone in the universe? The quest for extraterrestrial life is a multifaceted endeavor, encompassing not only the search for intelligent signals but also the exploration of our own solar system and beyond. Missions like the Mars rovers, the Europa Clipper, and the Dragonfly mission to Titan are all part of the broader effort to understand the potential for life beyond Earth. These missions aim to uncover the conditions necessary for life and to explore environments that might harbor microbial life, which could provide clues about the potential for more complex organisms elsewhere in the universe. One of the most exciting aspects of the search for extraterrestrial life is the potential for serendipitous discoveries. While we may not yet have definitive evidence of alien civilizations, the pursuit of this knowledge has led to numerous scientific advancements and a deeper understanding of our planet and its place in the cosmos. The search for life beyond Earth has inspired generations of scientists, engineers, and dreamers to push the boundaries of what is possible and to explore the unknown. As we continue to probe the mysteries of the universe, we must remain open to the unexpected and be prepared to embrace the possibilities that lie ahead. The discovery of extraterrestrial life, whether microbial or intelligent, would be a profound moment in human history, reshaping our understanding of ourselves and our place in the cosmos. Until then, we will continue to listen to the whispers of the stars, searching for a signal that may one day confirm that we are not alone in this vast and wondrous universe. In conclusion, the James Webb Space Telescope's potential discovery of lights on Proxima B represents a significant milestone in our quest to find extraterrestrial life. This groundbreaking finding, combined with ongoing efforts by the initiative